In this module, we will look at the aircraft's hydraulic system. We will start out with a system description. Next, we will look at the controls and indicators associated with the hydraulic system. The ATR 72-500 has two hydraulic systems. They are designated the blue and green hydraulic systems. The hydraulic systems are independent from each other and operate simultaneously during normal operations. The hydraulic system's main components are located in the left wheel fairing, aft of the main tires. These components include the pumps, accumulators, connectors, and the main reservoir. Unlike other aircraft, the two hydraulic systems of the ATR 72-500 have a cross-feed valve that enables one system to pressurize the other system's components. Each hydraulic system is pressurized by an AC Wild powered electric hydraulic pump. Each pump delivers hydraulic pressure at 3,000 psi. The blue pump is powered by AC Wild Bus 1, and the green pump is powered by AC Wild Bus 2. The blue system has an additional DC-powered pump that can be used to pressurize the blue system components when the aircraft is on the ground with no power. Even though you can cross-feed the two hydraulic systems, you should not cross-feed when the hydraulic auxiliary pump is being used. Even though the auxiliary pump operates like the other pumps at 3,000 psi, it is a smaller pump and only produces about a third of the output. This pump runs automatically when blue system pressure drops below 1,500 psi, the propeller brake is released, the gear handle is down, and at least one engine is running. The blue hydraulic system supplies hydraulic pressure to the nose wheel steering system, the flaps, the spoilers, and the propeller brake. In addition, the blue system supplies the emergency and parking brake system. The green hydraulic system supplies the landing gear system and the normal brakes. The two hydraulic systems use a common hydraulic tank that is located in the hydraulic bay. This bay is in the left landing gear fairing. The tank is a direct air fluid contact tank that is not pressurized. A baffle prevents splashing of the fluid and limits foaming. The total capacity of the hydraulic reservoir is 9.6 liters. A sight gauge is used to determine the quantity of the fluid in the reservoir. When the reservoir is full, the fluid level will be even with the upper mark of the sight gauge. A full indication means that there is a total fluid quantity of 9.6 liters. The lowest line on the sight glass is labeled refill. This line indicates the minimum quantity of hydraulic fluid required. When the reservoir fluid level is even with this refill line, there is a quantity of 8.5 liters. The aircraft has sufficient hydraulic fluid for flight as long as the hydraulic fluid quantity is above the refill line. When the hydraulic reservoir is filled, hydraulic fluid is added until the fluid reaches the normal filling level. When the fluid level is even with this line, the hydraulic reservoir contains 9.35 liters. Hydraulic fluid is added to the tank through the filler cap. Skydrol is the most common brand of fluid used. Approved fluids are Skydrol LD4 and Hyjet 4. The hydraulic tank is divided into two compartments that supply the blue and green hydraulic systems. Each compartment has a fluid capacity of 4 liters. The top of the tank divider is below the minimum filling level. If a leak develops in one of the hydraulic systems, the fluid quantity in the reservoir will decrease below the level of the compartment divider. At that point, the fluid in the compartment that services the system with the leak will continue to decrease until there is no more fluid remaining in that compartment. The other compartment will continue to supply hydraulic fluid to the other hydraulic system. Click on the tank to see the effect. Hydraulic fluid is added to the tank. The hydraulic tank is divided into two compartments. The hydraulic fluid quantity in each reservoir compartment is monitored by an associated low-level light on the hydraulic power panel located on the flight deck overhead panel. When the level in a compartment decreases below 2.5 liters,
The associated low-level light illuminates amber on the hydraulic power panel. The master caution lights flash amber. The amber hydraulic light illuminates on the crew alerting panel, and a single chime sounds.
2 drain ports located on the bottom of the tank are used to drain fluid from the hydraulic reservoir. 2 clogging indicators monitor the blue and green filters in order to identify the presence of particles that have entered the system. These particles could potentially cause clogging. The indicators look like turkey poppers and are visual indicators only. There are no cockpit warnings. They are located on the aft side of the reservoir. An overflow port relieves any excess fluid from the tank. This excess fluid may be due to overfilling or thermal expansion. After the hydraulic fluid travels through each system, it is returned to the hydraulic reservoir through 2 return lines located on the top of the hydraulic reservoir. We will now look at the green hydraulic system.
The green hydraulic system is pressurized by an AC-powered main hydraulic pump. This pump is powered by the AC Wild Bus 2 through the green hydraulic pump circuit breaker. This pump has a normal pressure output of 3,000 psi.
The output of the green hydraulic pump is monitored by a pressure sensor downstream of the pump output. When the green pump pressure drops below 1500 psi, an associated low pressure light illuminates amber on the hydraulic power panel located on the flight deck overhead panel. In addition, the amber master caution lights flash, the amber hydraulic light illuminates on the crew alerting panel, and a single chime sounds.
A temperature sensor is mounted in the return line of the green hydraulic pump. When the pump case drain line temperature exceeds 121 degrees Celsius, the associated overheat light illuminates amber on the hydraulic power panel. In addition, the master caution light flashes, the amber hydraulic light illuminates on the crew alerting panel, and a single chime sounds.
This indication may signify that bearing failure is impending for that pump. The corrective action for a blue or green system overheat light is to switch the associated pump off and then select cross-feed valve on. Once the system is cooled back down, reselecting the pump back on is permissible. Downstream of the hydraulic pump, the hydraulic fluid travels through a one-way check valve. This check valve prevents the backflow of hydraulic pressure into the green system pump in the event the cross-feed valve is open and the blue system is pressurized. The green system has an accumulator fitted in the line. The accumulator consists of a bottle that contains a charge of nitrogen. The nitrogen charge is separated from the hydraulic by a piston. The accumulator acts like a shock absorber against pressure surges due to pump operation. The accumulator also assists the hydraulic pump when there is a high demand on the system. The green hydraulic system pressure is indicated on the hydraulic system pressure indicator on the flight instrument panel. The pressure indication is in thousands of psi. The red tick marks indicate the alert thresholds. The sensor for the green system pressure indicator is downstream of the check valve.
The blue hydraulic system is also pressurized by an AC-powered main hydraulic pump. This pump is powered by the AC Wild Bus 1 through the blue hydraulic pump circuit breaker. This pump also has a normal pressure output of 3,000 psi.
The output of the blue hydraulic pump is monitored by a pressure sensor downstream of the pump output. When the blue pump pressure drops below 1500 psi, the associated low pressure light illuminates amber on the hydraulic power panel located on the flight deck overhead panel. In addition, the amber master caution lights flash, the amber hydraulic light illuminates on the crew alerting panel, and a single chime sounds. The corrective action for a low pressure light is to switch off the associated pump and then select the crossfeed valve to on. A temperature sensor is mounted in the return line of the blue hydraulic pump. When the pump case drain line temperature exceeds 121 degrees Celsius, the associated overheat light illuminates amber on the hydraulic power panel. In addition, the master caution lights flash, the amber hydraulic light illuminates on the crew alerting panel, and a single chime sounds. The blue system incorporates the auxiliary pump. This pump draws fluid from the Blue System hydraulic compartment. This pump is used on the ground to boost Blue System pressure when neither engine is running and none of the main hydraulic pumps are operating. Once the Blue System pressure is boosted, the parking brake may be reset or the prop brake can be engaged.
The auxiliary pump also develops 3000 psi of pressure. However, this pump has a reduced flow rate. The Blue System auxiliary pump is powered by DC bus 2 or by the hot main battery bus.
Normally, DC bus 2 is the power source for the auxiliary pump. If DC bus 2 is not powered, the auxiliary pump is powered by the hot main battery bus if the auxiliary pump push button is depressed. The auxiliary push button is located on the forward, left-hand side of the center pedestal. Once depressed, the auxiliary hydraulic pump will run for 30 seconds. The auxiliary pump will operate as long as the auxiliary push button is kept depressed. You should note that you can use this push button to operate the auxiliary pump even if no power is on the aircraft and the battery switch is off. If at least one engine is running, the auxiliary pump is powered by DC bus 2. The pump will operate as soon as one engine is running, provided the gear handle is down, the auxiliary pump push button on the hydraulic power panel is depressed, the prop brake is not engaged, and the blue hydraulic pump output pressure is below 1500 psi. The auxiliary pump will cease to operate if any of the enabling conditions is removed. If the prop brake is engaged when the auxiliary pump is operating, the auxiliary pump will continue running for 15 seconds after the prop brake is engaged. If the DC auxiliary pump started to operate because the blue main pump output pressure dropped below 1500 psi, the auxiliary pump will stop when the main pump pressure rises above 2100 psi. The output of the blue auxiliary hydraulic pump is monitored by a pressure sensor downstream of the pump output. When the blue auxiliary pump pressure drops below 1500 psi, the auxiliary pump low pressure light illuminates amber on the hydraulic power panel located on the flight deck overhead panel. In addition, the amber master caution lights flash, the amber hydraulic light illuminates on the crew alerting panel, and a single chime sounds.
A temperature sensor is mounted in the return line of the blue auxiliary hydraulic pump. When the pump case drain line temperature exceeds 121 degrees Celsius, the associated overheat light illuminates amber on the hydraulic power panel. In addition, the master caution lights flash, the amber hydraulic light illuminates on the crew alerting panel, and a single chime sounds.
The auxiliary pump supplies hydraulic pressure to the same line that is supplied by the blue hydraulic pump. One-way check valves prevent the backflow of hydraulic fluid into either pump. The blue system has an accumulator fitted in the line. The accumulator is exactly the same as the green system accumulator. This accumulator performs the same function as the one in the green hydraulic system.
The blue and green hydraulic systems are interconnected through a crossfeed valve. If one pump fails, pressure to the affected hydraulic system can be restored by opening the crossfeed valve. The crossfeed valve is controlled by the crossfeed push button on the hydraulic power panel. Click on the crossfeed push button to open the crossfeed valve. Once the crossfeed valve is opened, it will automatically close if the fluid quantity in either hydraulic reservoir compartment drops below 2.5 liters. This will prohibit adding fluid to a system that could possibly be losing fluid and prevents the other system from losing fluid and entering a low-level condition. If you recall, a fluid level below 2.5 liters will cause the associated low-level light to illuminate on the hydraulic power panel.
If either low-level light is illuminated, the crossfeed push button is inhibited and you will not be able to open the hydraulic crossfeed valve. There are no indications on the push button of the status of the crossfeed valve. The ON caption in the push button indicates that the crossfeed valve has been commanded to the open position. The only way to verify the operation of the crossfeed valve is to observe the indications on the hydraulic pressure indicator. The crossfeed valve is electrically controlled. It is powered by the DC standby bus. The crossfeed valve will automatically close if power is removed from the valve. The emergency and parking brakes have their own accumulator. The accumulator is located after a one-way check valve. Unlike the main hydraulic system accumulators, this accumulator stores enough pressure to allow for 6 applications of the parking brake. As you saw earlier, the hydraulic system is controlled by the hydraulic power panel located on the flight deck overhead panel. The systems supplied by each hydraulic system are listed under each pump push button. A simplified schematic of the hydraulic system is etched in the faceplate of the hydraulic power panel. The main hydraulic pumps are controlled by the associated pump push buttons. The push button and alert lights of the blue system push button are powered by the DC emergency bus. The push button of the green system is powered by the DC essential bus. The alert lights of the green system push button are powered by the DC emergency bus. Each main hydraulic pump is controlled by its associated push button. A pump is energized when the associated pump push button is depressed or in the in position. A pump is deactivated by placing its associated pump push button in the released or out position. The white off light illuminates when the push button is released out. Hydraulic system pressure is displayed on the hydraulic pressure indicator located on the flight instruments panel. The pressure gauge is powered by the DC standby bus. In the event of a loss of electric power, the pointers on the gauge will all move to the 0 position. The gauge can be temporarily energized by pressing the auxiliary pump push button on the center pedestal. This gauge indicates the system pressure in the associated hydraulic system after the check valve. The 2 lower indicators on the left and right of the triplex gauge show blue and green system pressures respectively. The upper indicator of the gauge shows pressure in the emergency and parking brake accumulator. Each accumulator, including the emergency and parking brake accumulator, have a pressure gauge in the hydraulic bay for checking on pre-flight. Unlike the pressure gauges in the flight deck, these gauges indicate the greater of system pressure or accumulator pressure. They will normally show the accumulator pressure of 1500 psi unless you check them while AC wild power is available or while the blue auxiliary pump is running. If brake accumulator pressure is insufficient, the auxiliary pump push button can be used to boost blue system hydraulic pressure and restore the brake accumulator to 3000 psi. This concludes the hydraulic system module.